Welcome to today's Explainer, everyone. We are diving deep into the absolute true mechanics of AI today. We're not just, scratching the surface. We're popping the hood on the technology that's literally reshaping software development, research, and honestly, our entire intellectual landscape. So let's just get right into it. I've got to start with a really direct question for you, and I want you to be totally honest with yourself here. Are you just calling APIs, or do you actually understand the model you're using? Because, look, ever since ChatGPT completely exploded onto the scene back in late 2022, millions of us have just slapped LLMs into our apps. But for the vast majority of developers, these models are basically just giant, mysterious black boxes. You send a prompt in, you cross your fingers, and boom, magic text comes out. But what is actually happening in there? It's a pretty stark contrast when you look at it. On one side, we have the API color. And honestly, this is where most people live right now. You rely on an endpoint, treat the model like a black box, and just hope it gives you what you need. But then, on the other side, you've got the LLM master. This is the dev who actually understands the underlying matrices, the person who can build the architecture from scratch, someone who genuinely owns the technology instead of just renting it from someone else's server. If you're looking to jump from that left side over to the right side, well, you're going to need a bridge. And that bridge is exactly what we're exploring in this explainer. We're looking at an absolute masterclass of a resource called Mathematical Foundations of LLMs from Equations to NanoGPT. Now, to be clear, this isn't just some dry textbook. It's a massive, bottom-up blueprint made specifically for developers and researchers who really want to close that giant gap between abstract theory and actual executable code. The goal here is wild, taking you from looking at a single line of mathematical equation all the way to building your very own GPT model. Section 1. Why math matters most. Look, we've got to address the elephant in the room here, the math. Why does it matter so much? Because you literally cannot master large language models without mastering the math that makes them tick. I'm talking linear algebra, calculus, probability, information theory. These aren't just annoying college prerequisites. They are the actual language of AI. LLMs are not magic, guys. They are pure, unadulterated mathematics. You need to know why matrix multiplication is the absolute beating heart of the attention mechanism. You need to understand how the softmax function takes raw logits and squashes them into a beautiful, predictable probability distribution. And you need to see how backpropagation, the literal engine of all neural network learning, is really just a mechanical application of the calculus chain rule to minimize errors. Once you can answer those things, you stop guessing and you start engineering. Moving on to Section 2, the 6-step learning method. Now, I get it. Math can be super intimidating, especially if it's been a hot minute since your last college math class. But that's where this resource's unique bottom-up framework comes in. It breaks down every single concept using a super rigorous 6-step methodology. You're not just passively reading equations. First, step 1, you get the formal definition. Step 2, you build intuition, usually through some really cool visual geometries. Step 3 is the derivation, where you actually walk through the math. Then, step 4, the fun part. Code implementation. You write it yourself. Step 5, you benchmark it to see how it handles. And finally, step 6 is application, where you see exactly how it slots into a modern LLM. You're basically building your understanding, mechanically, layer by layer.
All right, Section 3, from theory to code.
Theory is awesome, but as developers, we need to get our hands dirty, right? Well, get a load of this number, 33. The book has 33 chapters, and every single one of them comes paired with a corresponding Google Colab notebook. So you're not just flipping pages here, you're running experiments, you're tweaking hyperparameters, and you are literally watching the math come to life right there in Python and PyTorch. And this is where it gets incredibly cool. So every single notebook is completely accessible and designed to run on a standard CPU. But when you hit those core chapters, you're actively instructed to switch over to a GPU runtime. Why? Because you're going to run actual physical benchmarks comparing CPU and GPU performance. You get to experience firsthand the massive hardware acceleration that LLMs absolutely require. I'm talking about watching a matrix multiplication that crawls along for hundreds of milliseconds on a CPU suddenly drop to mere fractions of a millisecond on a GPU. It is one thing to vaguely know that GPUs are fast. It's a completely different ballgame to actually benchmark it yourself. Okay, Section 4. Deep dive, alignment, and optimization. Once you've nailed the foundations, the book throws you right into the bleeding edge of state-of-the-art LLM development. Just look at this modern LLM alignment pipeline. It's mapped out so clearly. We start way over on the left with pre-training, learning to predict that next token from mountains of data. Then we step into SFT, supervised fine-tuning, where the model actually learns how to format answers to instructions. But then the path splits. To make the model actually helpful and, more importantly, harmless, you can take the RLHF path, reinforcement learning from human feedback, which relies on reward models. Or you can take the much newer, highly efficient route using DPO, direct preference optimization, and this resource breaks down the exact math and the exact code for every single one of these stages. But here's the thing, making a model smart just isn't enough anymore. We have to make it efficient. You're going to take a super deliberate, hands-on dive into the most advanced engineering tricks used right now. You'll actually learn how to implement flash attention to optimize GPU memory so you can handle crazy long context windows. You'll get the mathematical intuition behind INT8 quantization, which is absolutely crucial if you want to squeeze these massive models into tiny memory footprints. You'll code LoRa, low-rank adaptation, so you can efficiently fine-tune huge models using just a single standard GPU. And you'll even explore grouped query attention to massively speed up inference caching. I mean, these are the exact same techniques powering state-of-the-art models like Llama 3 right now.
Which brings us to Section 5, building a nano GPT. This is the big one. All of that incredible theory, all 33 of those code notebooks, they all culminate in this one massive, thrilling project. You are going to build your very own nano GPT entirely from scratch. Inspired by Andrej Karpathy's famous work, you'll literally assemble the modern transformer blocks yourself. You'll write the code for rotary position embeddings, or ROPE, to give your model a sense of sequence and order. You'll implement the grouped query attention, build out the Swiglu feed-forward networks for that nonlinear reasoning, and then you pre-train the whole thing on the tiny Shakespeare dataset. You'll even write your own top K and top PD coding algorithms to intelligently generate the text. And for the grand finale, you fine-tune your creation into a fully functional, friendly little mini chatbot using QLoRa. You literally build a complete, modern AI pipeline with your own two hands. How cool is that?
Section 6. Master LLMs today. So what's the real takeaway here? How does all of this actually transform you? Well, it's pretty simple. It is time to stop guessing what's happening under the hood. By going through this journey, you master the underlying math and the code from the absolute ground up. You stop being someone who just consumes AI, and you become someone who genuinely builds it. And let's be real, this isn't just about learning some new syntax. This is about deeply empowering your career by becoming a true AI builder who intuitively understands the fundamental fabric of this technology. Thanks so much for joining me on this explainer. If you want to jump right in, you can find the official GitHub repo with all 33 Colab notebooks, the benchmark code, and that entire NanoGPT project at the link right here on the screen, bit.ly/4f1ys. Definitely go poke around the code today. And to get the full guided 6-step experience we just talked about, you can grab a copy of Mathematical Foundations of LLMs on Amazon right now. I want to leave you with one final thought. We are literally in the middle of the defining technological revolution of our time. So, are you going to be a spectator who just relies on other people's APIs, or are you going to master the math and build the future yourself?